Hello there. We are going to look at functions, specifically their notation, and then operations of function and composition. So notation first. If I have a function that I define as being f of x is equal to, and I'm just going to keep it very simple here, let's just make it 2x plus 1, that's a linear function. Here is what we cannot do. If I want to evaluate this function for x equals 3, for example, what I cannot say is f of x is equal to, and I'm going to plug in, I want to evaluate it for 3, so I'm going to say 2 times 3 plus 1, which is equal to 2 times 3 is 6 plus 1 is 7. This is not a true statement. This is not true. That's not equal, right? F of x is equal to this rule, this 2x plus 1, this function. Once I plug in a 3, or any number for that matter, for x, then that x up here in the notation has to be changed also. So what I would have to write is f of 3 is equal to 2 times 3 plus 1 equals 7. You can say, well, Mrs. Williams, you're really being picky because the answer is going to be the same anyway. So does it really matter? Yes, it does. Every time you put an equal sign, you better make sure the left and the right of that equal sign are actually equal. Otherwise, you're lying. You're just flat out lying. I know you don't mean to, but it's a lie, right? So don't lie to me. Just don't lie. To anybody, for that matter. All right, so that's just for a little bit of drama here, just to insist that it's very critical that you pay attention to that. Here is something else you don't want to do. Let's imagine I have a function that's called g of t is equal to, or I don't know, let's make that t to the second power maybe, right? And when you're writing that and you're going to work with it maybe, you might just say g of t equals x squared, and you change that t to an x. Well, that's the same thing. This is not a true statement, right? If your variable given to you is t, you have to respect that variable. You cannot say, oh, I don't like to work with t's, I'm just going to call it x and it'll be all just fine. It doesn't work that way, right? When you were born at the hospital, maybe, and your parents gave you a name, let's say they called you Paul. The nurse cannot go and say, oh, I don't want to call him Paul, I'm going to call him Mark and write Mark down on the paper, right? It's not for her to decide. So same thing, when you are given a function with a variable in it, you're going to respect the variable that you're given, right? Right? So now let's do, let's see, I'm going to say example 1. Let's call that example 1. F of x equals, and we're going to do, let's imagine I want 2x squared plus x, and I want to evaluate this for a, we're going to say let's evaluate that for f of negative 1, right? So we're going to say that's equal to 2 times, plug in your negative 1 where you had an x, everywhere where you had an x, right? And then that would be negative 1 squared is a 1, 2 times 1 is 2, and that's minus 1, and that would be a 1, right? So f of negative 1 is 1. Now here is what you could be doing. If you're given this, and that's already written down on your paper, and you don't want to rewrite everything like I did up here, and you just want to show that you're evaluating this for x equals negative 1, you can put a such that bar, right? That's such that x equals negative 1, and then you're going to plug in your negative 1 everywhere you had an x, and the answer will be 1. That you can do, because that will be mathematically proper language. Okay, so now let's say I want to evaluate it for f is equal to, let's do 2a, for example. What does that mean, really? Well, it just means wherever we had an x, right, we replace it by what's in here. So I'm going to have 2 times 2a squared plus 2a. And so that will be 4a squared times 2 will be 8a squared plus 2a. And that's it, right? And now let's make it fancy. Let's spice this thing up a little bit. Now let's say I want to evaluate it for f of x plus h minus f of x all over h. Let's just be very fancy and say, hey, let's say we want to do that. Okay, well, what would that be? Wherever I had an x, I need an x plus h now. So wherever I had an x, I'm going to have an x plus h squared, and then x plus h. That's for that portion. And then I'm doing minus. Wherever I had my f of x, I'm going to plug that in instead, right? So that f of x, be careful because f of x has 2 terms and you're subtracting, so make sure you put these parentheses there. And all of that is over h. Well, there is no x here, that's not a function, that's just an h, so it just goes down there. Now we're going to expand. So this is x plus h squared, so that will become 2x squared, right? And then xh and xh, that's 2xh times 2 will be plus 4xh. And then h times h is h squared times 2, that was hard to say, 2h squared, plus x plus h, right? I can just drop those parentheses, don't need them. And now I need to distribute this negative right there, so minus 2x squared minus x. Let's make sure we have that right before we keep going. So that this binomial becomes x squared plus 2xh plus h squared, and then we multiply all of that by 2. So 2, 4, yes, okay, so we're good. All of that still over my h, right? And now I'm going to see if I can simplify anything. So let's look. I have a positive 2x squared and a negative, positive x and a negative x. And I think that's it, right? So what's left over up here? Well, I have a 4xh left over, and a plus 2h squared, and a plus h, and that looks like it's it. And now look, we have an h everywhere, so we're going to factor out an h in the numerator. So we have 4x plus 2h, right? There is still one h left here, and then plus 1 over h. And I wanted to do that because see, now I can I can cancel that. And so my answer will be 4x plus 2h plus 1. And sometimes you're going to see they're going to get crazy like that, and they're going to get crazier before they get prettier. Okay, so that's a little bit of evaluating functions. Sometimes, so let's do example 2, and let's not make those functions too complicated. Let's imagine we have f of x is equal to negative x squared plus x, and g of x, let's imagine, is equal to 3x. And what we want to do is we want to find f plus g of x. Notice how I do my operation using function notation here. That just means that I want to add the two functions together. So, and then this is just my input, right, my variable x. So I want to add them, so I'm doing negative x squared plus x plus 3x. So that will be negative x squared plus 4x, right? What if I wanted to divide them? Well, f over g of x, right? Function notation for the operation of division here. So the f of x, I want it on the top, so negative x squared plus x divided by 3x. Now I notice I could factor out an x, and that will then simplify with this one, right? So I'm going to do that. So I'm going to actually factor out negative x, and so I'm left with x minus 1, right? If I take out a negative x, and down here it's just 3x. And now those x's would cancel, so I'll have a negative and then x minus 1 over 3. And here I have to precise x cannot be 0, right? Because we cannot have a 0 in the denominator here. So that's addition, division. Sometimes you want to do something like negative 2 f of x minus, oh, I don't know. Let's do g of x over 6, for example, right? So let's do plus here, why not? So negative 2 times f of x means you just take that function and you multiply it by negative 2, right? So this time negative 2 is 2x squared, and then x times negative 2 is negative 2x, and then plus g of x divided by 6. So g of x is 3x. 3x divided by 6 will be x over 2. And now I have like terms. They don't look like it, but they are, right? Because this is the same thing as 1/2 x and negative 2x. They go together, right? So we have 2x squared, and I have a negative 2 plus a 1/2, right, of x. So this will be a negative 4 plus 1 is negative 3, so that's negative 3/2 x. There we go. So that was just a very quick review of function notation a little bit and sum operation. Now let's look at composition very quickly. So if I wanted to do composition, and let's just keep those two functions we had up here, and I wanted to, for example, find f of g of x. This, I need you to remember, can also be written as f of, with that little bitty open circle there, right, g of x. Those two mean the same thing, right? It just means I'm taking my g function and it becomes my input wherever I have an x into f. So that just means I take this g and it becomes wherever I had an x in my f function. So that would be negative 3x squared plus 3x, right? Those right there are your g function, right? And they were your x's here, so we take that and we plug it in here for x. And now we simplify. So that would be negative 9x squared and then plus 3x. So that's a composition of function. Oops, you didn't even see that. Now, let's do it backwards. Let's do, or the other way, g of f of x, which can also be written as g of f of x. So now I'm taking f of x and I'm going to plug it in where I have an x in g. So that will be 3 times my f of x, right? So negative x squared plus x. And that will be negative 3x squared plus 3x. Attention, attention. If you don't remember from Algebra 2, those two are not the same. They are different, right? So the composition of function is not commutative. It is very important that you do it in the right order. It's not commutative. The only time you're going to get the same thing is when the two functions you're working with are inverse of each other. And that's the purpose of the next video. Now what if, just quickly, I wanted to not do f of g of x, but what if I wanted to do f of g of 2, for example? A number instead. Well, that just means you're going to take your 2 and you're going to plug it into g. So f is not changing. So f will be negative my g of 2 squared plus my g of 2, right? And so those x's become g of 2. Well, what is g of 2? Well, g of 2, if you plug in a 2 there, g of 2 will be equal to 6, right? 3 times 2 is 6. So that's what those become. That's your g of 2 right there. And now you just finish. So negative 6 squared is negative 36 plus 6. And so the answer will be negative 30. So when you have a value given to you, you're just going to plug it in into the inside function first. And whatever output you get, that becomes the input in the outside function. Okay, very quick review of a few things about functions. Now the next review is going to be on inverse functions. Talk to you soon.